go back to the slides, the second hands-on session, which is more realistic, in a sense, it's using the deep neural network to help identify and classify handwritten digits with carriers. Again, we open in Google Calamitary. And if you want to know all the details, you can directly go to the GPU Notebook. And we start with the loading part, where we load all the necessary modules, mostly TensorFlow related. And then we have matplotlib for plotting and NumPy for some functions used in NumPy. And then the very first thing we do is to load the data and then split the data into training dataset and testing dataset. So the mist.load data, this function is already doing the splitting for us. By default, it's I believe it's 80 to 20%, 80% training and 20% of test. And then we do the plot out the first 15 images in the dataset. We simply start the run function. And then we normalize the data to make sure all the data is in the reasonable range without very big numbers, very small numbers, so that we can get all the dataset printed out and analyzed. So we start building the sequential model, which is simply adding layers, stacking up layers one after the other. We first add in a flattened layer to turn all our 2D images into 1D big array, and then we add in dense layers. 2 of them with 128 neurons each, with ReLU as an activation function. The last one, because it's a classifier, so we use a softmax as an activation function with 10 neurons. Each maps to the category that we are going to classify. And then we compile the model with a random optimizer that we talked about previously. And then we have a sparse categorical cross entropy, which is the loss function used for classifiers usually. And the metrics we want to use for outputting and evaluation is accuracy. Because for every classification problem, you can easily compare to see if your classification is correct or not, because it's a elaborate data set. And there is a need for loading TensorBoard if you want to go into the details about training process, if you want to look for the variation of your accuracy and your errors, and you can use this TensorBoard to do that. Then you start the fitting process, which can take a pretty long time depending on the size of dataset and depending on the iterations you want to go through. And finally, you can print out the summary, or you can do this early after you get that. Before you train the model, you can output the summary, which shows you the structure of your neural network. As you can see, even for this smaller one, we are already using about 118,000 parameters, and all of those are trainable. And then you can test the accuracy. In our case, this is very good. We get up to 97% of accuracy using the test dataset, which was not used for training purpose. So that's why we do the splitting first. And you can save the model into HDF5 format, and then you can load it up. So the reason I want to show you here, you can just save it into a file, and then you can load back into your memory. Basically, what you will be using after this load model function is that all the data was actually from the file, saved file, not from the trained model anymore, because after we save and load it, all the model we are using for this will be from the saved file. Then we do the prediction. And simply we take X text as the input. Your predict function takes, you can take a single input value, or you can take an array, and your output will be correspondingly be an array, and you can plot it out. So these are the ones, because the accuracy is pretty high, it's 97%, almost 98%. So I only try to print out the predictions that was not matching with ground truth. Here, it's a digit 3, and our prediction is 8. which it's understandable because 3 and 8 in some ways, depending how you write it, it's kind of similar. So these are the ones are not correctly predicted in the testing dataset. Actually, only one here. So if you want to run TensorBoard, you can uncomment the following and to run TensorBoard on Google Clamp3. So I won't show it here. If you want to try it, you can try it yourself. So with that, we all conclude our module on Keras, and I hope you all learned a bit more about deep learning, as well as how to use Keras and TensorFlow to train a very simple model. So the major problem with deep learning and all the other similar machine learning projects is the dataset. If you have a high quality dataset and if your dataset is very specific to your application, you might be getting very good results. If you have not high quality dataset and your model might not be giving very good results. The neural network here, it's always good to get started with simple ones, like the dense layers here, and also you can start with convolution neural networks. And then after you finish all the testing, you can start using some pre-trained models to get started. We'll not go into the detail about transfer learning and other things to use the pre-trained models, but in the future modules we'll be presenting along this series. We'll talk more about those advanced topics. Thank you. Bye-bye.